And welcome. Once again, I am the database guy. Glad you have joined me. We're on video 5 in presentation 9, the VBA course, which is is a sub-course within the main course of course, the Microsoft Access SQL Server development. And it's going to be very large when we're still in the basic area that I consider it basic because we have really gone over the if-then, the select case. Whoa. Fix that up for you. Message box, and we are going to do the for loop. We're going to start loops. And loops are interesting because they're ways of moving through data effectively, rapidly, and so on. We're going to go back to our function code here. Well, I'm going to insert a new module. We're going to call this one BAS loops. There we go. And yeah, good. All right. We're going to save this. Yes, you can call it that. And we're going to, again, a function usually returns a value where a subroutine does not, but it's not always true because I can run a function through something and process something repeatedly if I want, as we've said, but usually it returns a value. So function and loop test, right? So we're going to declare, or implicitly, our dim y as long. It's a long integer. And in the loop, we're going to say for y equals 1 to 10. And then what we're going to say is just debug dot print y. Well, actually, lng y. You don't have to say lng y when you're dealing with numerical data like this. We can leave it as this. If you wanted to, you could have long y and so on. We can do that. And let's just keep in consistently with what we had. At this point right now, I'm going to do a debug just for fun here. And it actually, see if it caught anything. Yeah, syntax error here. Okay, this is just an old, from our other code. I must have put an extra character there. Yeah. And let's close this down. Let's go back here. I think I'm going to flag an error. That's my point. Yeah, 4 without next. And there you see it. We don't have the next. So whenever you have a 4, you need a next. And one of the things that is interesting about the for next loop is you could leave out the variable, but it's not recommended. So it's next lngy. Now we're going to do our debug, compile, everything is nice. And I'm going to just bring this little immediate window a little bit up there, and we're going to go I'm sorry, loop. Boy, I'm thinking of that variable, huh? And there you can see it spit out 1 through 10. So it loops around. So what does it do? It says for long y equals 1 to 10, it says, all right, print the first value of long y, go to the next value. So now you're at number 2. And you print that out, and you print out 3, and you go to the next one, and 3, and so on and so forth. Now, what's interesting here is you could run the step here. And we're going to go back to this and do this. And you see here, it starts off with 1, right? Then when it goes to the next lngy, it's going to step 2 places above that. So we're going to go to 3, and then 5, and then 7, and then 9, right? We could have done it with, now here's what we're going to do too, by the way. I'm going to just change this for a minute. before I go into what I was going to say. We're going to start from 0. And let's leave out the step. And we're going to run this. So we're going to get from 0 to 10, which is really 11 pieces of data, but that's fine. When you got to think about this too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I want to make a loop of 10, this one's not really going to be what I expect. So let us go to 9. And you got to be careful. How many times do you want to loop? You've got to make sure you captured that. And now we have 10. We've gone through 10 loops. So if I were going to process something, anything, whatever it might be, 10 times, I'd want to go from 0 to 9, not 0 to 10. That would be 11 times. Or I'd go from 1 to 10, as you saw before, but generally you don't start at 1. Now, let us, now step 2. Okay. And now we see 0, 2, 4, 6, 8. Okay. So what I'm trying to is, if you don't have a step there, it takes 1 as the default. If I, for some reason, decided to get a little unusual, this piece of code is not even needed, because if I do this, right, I'm back to the original step 1. Okay. Now you can also do a -1, but you got to be careful here. You got to go from 9 to 0, because you've got it. You're taking 1 step down from, right, and I'm going to do -2, by the way, not 1. So let's see what we get, and we get 97531, right? So if I had done this with a step -1, you should get everything. And you do. So you can do a minus step. All right, that's one possibility. Let's try -3 and see what happens here. So we're going to start off with 9, so we should have 6 and so on. Yeah, 630. Right, which is good. So this next type of, and we're going to just go back from 0 to 9 here without a step, meaning we're going to, wow, 0 to 9, meaning we're going to go from, we don't have 10 steps. Now, we're going to put in, comma, lng x as long as well. Now you can loop these, so I can say then in here equals 0 to 5, right? And I can do a debug dot print lngx, next lngx, and let's do a check on this. Okay, we're good. Now, what's going to happen here, and I want you to think about this, is when it gets to the first lngy, actually we're going to say gx plus lngy. All right, so when we get to the first one in the loop, so what's going to happen here is you are going to have 0 as your first lngy. When you get to your first lngx, it's going to print 0 plus 0 is 0. The next one will be 0 plus 1, 2, 3, 4, and 5. So you're going to go from 0 to 5 as your total. And then you're going to loop to the next y. And you're in 1 now, and so on. So you're going to have 5 times 10, or 50. And let's see what happens. And we did 0 and 0, right? Because the first one is going to be 0 and for y, and 0 for x, and that's going to be a 0. Then we're going to have 0 for y and 1, right? So actually what's happening here is, and let us rerun this, but let's take this out because I think it is confusing everything. That's 1, 0 for y, 1, 0 for x. Let's go back and run it better. So here we are, 0, right? 0, 1, 2, 3, 4, 5. Let's see, yes, 0, 1, 2, 3, 4, and then 5. That's the first loop for the x, right? So 0 to 5 is actually 6. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Right, that's 6. So you're down here and you have reached now the end of the first looping for the x. Then the next one, y is now 1. 1 and 0 is 1. 1 and 1 is 2. 1 and 2 is 3. 1 and 3 is 4. 1 and 4 is 5. 1 and 5 is 6. Now we get to the next y of 2 and we keep going. 3, 4, 5, 6, 7, 8, 9, which is our last one. So we should have 9 and 1 is 10, and 9 and 2 is 11, 9 and 3 is 12, 9 and 4 is 13, and 9 and 5 is 14. So in total, when you count, you're doing 50 of them, all right? 50, because you have a loop within a loop. So why do I bring this to you? All right, the important part of this is that you got to be careful putting a loop within a loop. I have seen instances where if the loop is so large, it will lock up the database and you will even break the stack. They call it the stack. The amount of data is overfill, too much data. So you want to be careful if you're doing this loop within a loop, and you do it on occasion. You'll utilize it. We'll show you at some point how to use this. Mostly when we're looping, we're doing things to record sets. Boy. And it's one of those that will, let me put it to you this way, it will allow you to go through all of the data within a particular table if you wanted to search through it. And it does it quite rapidly, as you could see. And we're able to then either find the first record with a certain criteria, or find the next record with a certain criteria, or count the number of records, or do something like that. We're able to what's called parsing a lot of data. And we can actually do this too with controls. We can look through controls on a form and find all the controls. And I mentioned this whole thing about tag a while back with a certain tag value. And we can determine whether they have data within them to make sure that we validate that. So there's a lot of tools you can use with the for loop, which is really called a for next sometimes loop. Now, coming back here, there's a for each loop as well, which is a little bit different. And let's copy here. Oops, sorry, I put that little stopper there. That little stopper there is to stop code from executing. We're going to go for loop test 2. Let's see. Here, collection all as new collection. Now, what I'm doing here is we're using a collection, which is really what I would call an array of data, right? So when we use a collection, okay, we are going to parse through that collection, right? So we can add to the collection first, right? And when you're doing this, COLLALL dot add, you could add to the collection, you can remove from a collection. So first thing we're going to do is for LNGY equals 0 to 4. We're going to go 5 pieces there. And then we're going to go collection dot add. Wait, I'm sorry, collection all dot add. And we're going to have it as LNGY is our first one. And, oh, the item and key. So we have to add the item. Uh, All right, so we're going to have to add something in here. Yeah, I know, I didn't finish it. So string item as string. We need to add a string to it, and we're going to say string item equals um, LNGY. I'm going to concatenate that with test. And so here we're going to have to add the item string item, comma, and the key will be LNGY, 0 with 1. Hang on a moment. All right, yeah, we're not going to use parentheses there. So we're saying here we're going to add the item in question, which should be 0 test. Well, let's do it this way. Let's do it this way. Test number equals, and we're going to concatenate with LNGY. Y. The test number is 0, test number 1, and so on. And then we're going to go next LNGY. Now let's debug it. Good. So what we're saying here in our code, we're going from 0 to 4. We're going to create a string item called that one. Test number equals 0. We're going to add it to our collection, and then what we're going to do is go to the next one and continue that, and let's see what happens to that. So type mismatch here, we're getting. Oh, I see why. So, all right, we're going to have to, right, I think I know what it is. Reading it back requires you to, let's see. Okay, we've done it. So, if we go to read that back now. So let's debug.print. And I don't think we're going to be able to do it because it's local to it. It's not a, yeah, it's going to be local to it. So we're not going to be able to read back on this one. Yeah, so we're not going to be able to read back on it. But what we'll do here is after we do that, we will then lngx as long. Okay. And actually, we're going to do the for each one here. So for each see, it will be for each item in collection all. Then what we're going to do is we're going to, let's see, debug.print. Actually, we're going to do it this way. We're not going to do it for each item, but for each LNGX in collection all. Then we're going to debug.print collection all LNGX. So let me just see that the IntelliSense GX should. Next LNGX. So debug compile. And see what it gave me for an error there. Oh, object. So we're going to have to make this a variant because it won't go with long. Variant. As I like variant because it's a little bit better. So now let's see what it does. Yeah, subver function not. Oh, I see. Boy. COLLALL collection all, and our index is going to be LNGX. That's what we need. We need the index. So we're going to start the first object, the second one, the third, and would look like good. Let's see if it errors out. Invalid procedure caller argument here. Oh, okay. So, we have on this one here. Let me just go quickly to my code back here. In collections on the for each loop. So dim_i is variant print I. So just see that one more time. Oh, okay. So I don't have to worry about calling it out within the collection. I can just do it here, LNGX. It should work that way fine. And that's what I don't really use this so much. And there we go. Here it is. I don't typically use the for each, but basically what you do is, and you can see it right here, is I put all the items in the collection and I extract them back out. And there is a particular website that has all these statements. This one haven't used much at all. But you can use it. What I tend to do is I tend to run a simple for next loop, and then what I do is I use the identifier. So what I would do would be, let's do a loop 3 test. What I would do would be, this would be a long, as long, because I don't usually use the for next each. So what I would do would be for LNGX equals 0 to 4, I would then debug print COLLALL collection. Do I have it right? Just see. Oops, sorry. Yeah, I know. ALL. Okay, it's because. Oh, it's an ambiguous. That's why. We need to do 3. I forgot to do that. That's probably why it's not calling it. So then I would do here, I would say COLLALL. All right, so now we're back. And the index item I would have would be LNGX. So I would say, give me the first item there. Oh, I would debug print, by the way. I mean, that's what I'm doing here, but I would normally use it in a different one. And so, compile, we're good. So what we're going to do here is loop test 3. It's going to say subscript out of range. Let me see here. I'm at 0. So on this one. Oh, okay. So we're going to call this, I know what it is. When you're referring to items, I think it is here, we need to have, that's the reason why it's giving me that error. Usually, there we go. You need to have 1, 2, 3, 4, 5, not 0. You need to start at 1. So I'm just going to bring you through this one more time. The 2 ways it can be done, right? So in loop test 2, we added each item, right? We said, okay, let's look at our code. And we said, we're going to declare implicitly, or implicitly declare a item long Y as long, collection all is a new collection. And by the way, that new term, reason why it's structured that way is if I declared collection all as collection, I would have to set it to a new collection. Actually, I'm going to do that down here and show you what happens. So what you would have to do here would be, so you can see every aspect of this, you would have to set, and this is the first time of your set statement, set COLLA all as new collection. And, oh, I'm sorry, equal to, not as, but equal. So you'd have to set the collection equal to a new collection, meaning you're instantiating or creating a new collection. What I did before here is I actually did that when I declared it implicitly, which is easier. So if I run loop test 3 again, I should be fine, and I am, all right? But I have to have this extra statement here, which I don't need. So let's go back to loop 2 first. For what we said, declare implicitly that long Y is long, and our collection all is a new collection. Therefore, I don't have to instantiate it or make it a new collection. You know, I can create as many variables as collections I want, but the minute I say new, it clears the collection out and starts it fresh. And then string item is string. We needed to have a string item there, or a string, and long X is variant. Okay, so what we did here is we said, okay, in the for statement, and I'm going to just for long Y equals 0 to 4. So we said from go to 0 to 4 or 5 emanations. String item equals the test number, which equals that string plus the long I value, which means the first one will be test equals 0, test number equals 0. Then we're going to add that item to the test collection, and we're going to the next one there, as you see, okay? And then what we're going to do here is we're going to say for each long X in collection, and actually what I'm going to really do is this should be variant X. We should again describe it as it should be. My goof. Print the variant X and next variant X. And then end the function. And so what you get here, as you saw, and it doesn't matter how many, you could have 5,000 or 500 or 50 or 5. It's going to print everything. And that's why loop test 2 is a very powerful loop. Now when we go to loop test 3 here, which is different, we declared implicitly long Y is long, the collection as a collection, the string item as a string, and the long as X is a long. But then we had to set the collection equal to a new one each and every time. So that, again, we could have declared that collection all as a new collection. It would have saved us time. Then we did the same thing in the first one, and I'm doing this so that you can read it better, and always write your code for readability. It's no different than the first one. The next loop, where we're going to extract the data from our collection, this is the one here, where now we set it for 1 to 5. And again, we had originally had 0 to 4, but you can't. Your first item in your collection is 1, not 0. And I missed that one on that one. But anyway, this one here, so if I were to have, and let's try it, 0 to 7, right? And I would have run loop 3. I only get 5. All right, now let's go back here and run the 7 here on loop 2. And we're going to just do this and just backspace and go 2. We get all 7. So you see how powerful it is to be able to loop through every item in a collection. So your for each is very, very important because it allows you that ability to look at everything that's within a particular collection. I basically will, when I do a for next or a for loop for a series of controls, I'll look through every single control. All right. But I'm doing it almost like a for each, okay? And I will do it to look through, and you can do that. You can use the for each for controls, for each control in form, whatever, and you want to look through every control and find those with that special, um, uh, what was that? Let's see if we can take a quick look at it here so I don't misinform you. On the other sheet, the tag. Yeah, the tag. That's the one I'm looking for, the tag. You go through and you find the controls that only have that tag, and you validate only those controls to see if there's data within them. Life is easy. It shortens up your way. Less is more with code. So in looping here, this is interesting because one of our loops is specific to the number of counts that we have, our for next loop, or our for loop. Our for each next loop, which is our for each loop, we can go through everything we want to see. And you see here, I'll see everything in this loop, but I'll only see 1 through 5 in this one. And I need a variant. So here, in this one here, I can use long integers or integers, but here I need a variant. Why? Because what I'm saying here is, for each item, which is really what the variant is, in a collection, I want to be able to print each item, and which is what I did. That the item is a variant because it's stored within the collection. Now, we haven't gotten deeply into collections, and we will in our intermediate VBA programming, because collections can go like an array, can be one set of data, or can be multidimensional. I can have 2 or 3 sets of data in my collection, and I can store them. Now, generally, when I'm working, I only store an array or a collection with one set of data. So it's only one-dimensional in that sense, but I want to show you everything about collections so that you know how to use them when the time comes. And the for next loop is, or the for loop is an interesting, really interesting one that allows us to process data like crazy. Without it, we couldn't do that, right? So where does it come into play? Where are the important places it will come into play when you use it? Let me just write it over here. One, it will be in manipulating data. So if I want to process data, go through data, and run it through a loop, I will use that. Extracting record, extracting field, or how do I put the record sets? Just say record sets, right? Record sets and fields. So you're going to see this one and how it works. Boy, I'm bad. And how it works. So in other words, you can, let's say, parse record sets and fields. And then the last one really would be also to parse form or report controls. Mostly forms. Mostly forms. Because reports, we don't generally validate them, but there may be a need to check or to look at the data on a report for some reason, but you could do it with either one. And so, and I'm going to put here on the manipulating data part, counts, sums, etc. So when you're looking at, there I go again. When you're looking at data and having to do something to it, and that is, could be form data, could be, I'm going to say form data, could be form data, form or table data. But table data, you would use uh, you're parsing the record set. So I would just say form data here. I'm not going to give you a confusing thing on that one, but so and basically what happens in the for next loop, as we saw, is it is set for a specific amount of data. So either you're going to have a certain number from 0 to something, from 1 to something, from 10 to something, or you're going to have a certain number of items in a collection or in a form or controls within a form or something like that. So this particular one here, going back, go up one. So this is sort of a static loop based on limits of controls, records, or values, and values being the numbers you set. So if I set from 1 to 7, that's what I'm going to get. So and the for loops or the for each loop, as I said, can be used in the manner of which I've described here. Let me bring this down for a moment. So as you see, our first loop test was a simple loop test, and we nested them. That's another thing. Got to be very, very careful with nesting them because they can get to be extraordinarily large. Our second loop test was we looped through and added items to a collection. And while we're here, you have the add, count, item, and remove. So if I did collection item, I'd have to do the index to it here. And that's what I was talking about. So in other words, on the third one here, actually what it should be, dot item, LNGX. I think this will be fine, but 1 to 5. So let us run that loop 3 and see what we get. Loop test 3. Let's see. Where are we getting the error from? Oh, I didn't spell it right. Again. There we go. So I could have left it, as you see, the two options are collection, all, and if we go back to that. But the real correct one is that. So it says look at collection, look at the item and that number and print it. That's what you want to see. So going back up to, let's see, where were we here? Right, so you have some methods. These are methods for the collection. You can add an item, you can count the number of items, you can remove an item, you can list an item, and what we're going to do here, yeah, it's a compile error because I haven't finished writing it. That's another thing too when you do that. So first what we're going to do is we're going to collection all dot count, and we're going to debug print that so you can see the three methods on the collection item. Right, so it says 8. It says 8, which is interesting. It shouldn't be 8, but oh, I know why, because it's 0 to 7 here. That's why. It is 8. So let's bring this out from 1 to 8. And let's see. Yeah, there we go. So, right. So It's actually 8 because we put from zero, set from 0 to 7, and that's going to be 8 items. We're going to add 8 items. Shit. And then when we take it out, we'll know what we have within that. So, you learn that on the collection. Oops, sorry, let me put that back. Um, let's see. So on this collection, we noticed we had 4 different methods: add, count, item, remove. Now, if I ran a remove to this here, I would be removing everything. And I could do that. I could say remove item 0, 1, 2, 3, 4, 5, 6, 7, 8. And then let's see here now what would happen. Let's just try that. So let's see what would happen instead of debug print. Actually, you know what? Let's leave this alone. Let's do it in a separate loop test just to finish off this little. Here we go. We got to put 4 in here so we don't have ambiguous. Now, what we'll do here is instead of debug printing this, we're going to say COLLAOL dot remove index LNGX, right? And then what we're going to do, after we do all that, we're going to say, and again, collection will be existent within this function, debug dot print collection all dot count. So what should happen here, if we're good, is we should start off with a count of 8. After remove, we'll have a count of 0. And it didn't print it. Let's see. Oh, we're loop test 3, not 4. Boy, that's, yeah. So loop test 4 is the one we want. Subscript data range, and let's see, 5. So, let's see. Let's stop it for a minute. Let's debug.print collection all.item lngx. So let's see here what happens on 4. All right, so it got to, oh, I see. It got to, did we run a step on this? Let's see, 0, 2, 4. 2, 4, 6. So it got to the 5th item and it's not there. Eight. And let's try to take the remove off of here. Let's this, yeah. Always do that when you're troubleshooting. And let's see. Okay. So, I think the remove, what it's doing is it is removing. Let's just see how it is actually working on the remove. Usually you remove one at a time. Let's see. So 0, then it removed 1. Oh, I see. So it removed 1. Then it went to 2. Yeah. Okay, so in the remove space, you would have to have it. Let's see. So it's removing. Go to my debug. 5. So the 5th one is not there, and it's telling me I don't have that item there because I've removed them. Okay. So Let's see what happens. If we get rid of that without debug printing it, will it give me an error too? It probably will. Yeah, see a subscript out of range. It wants to remove 5, but 5 isn't there. I think what's happening to it, and I'll tell you, is when it removes an item, that means there's one less in the, oh boy, come on, get back in there. There's one less in the collection, and so when it goes to the next item, it'll keep removing those items, and it loses the point for which, or the place for which it's at. So in other words, looking at this here, right? So I debug print test item number 1, which is test number 0. Then I remove that item. Okay, number 0. Yeah, let's just see what would happen just for removing 0. So collection all dot remove index 1, just 1. Let's see what would happen. Should. Yeah, it's still giving me a subscript out of range because it's still doing that. It's saying, hey, I can't find 5. So it's breaking up the collection in such a way. So if you got to remove something, don't do it through a loop. You're going to have to do it for a specific item to remove it at a specific place in time. Let us do it this way then. Take it out of the collection and bring it down here. Now if I do that, let's see what happens. And it should be fine. Right, so now I have 7. Okay, so and the one that's removed is the first item. So that's test number equals 0. If I were to print this out, I'd have from 1 to 7. But when you do it in a loop, what will happen will be it will leave a gap. And so you won't be able to go to the next item. In other words, the loop is dependent upon the cycle of the number of items in your collection. But anyway, just showing you the 4 methods of a collection, which is an array. We're going to get heavier into that when we do our intermediate programming. So you've learned the for loop. You've learned the for each loop. You've learned what it can do. We're going to go back to these when we go back to record sets and things of that nature. You're going to see them again. When you do, you'll understand how they're really used in practice. So in other words, an example of that would be I want to validate the data. As I said, I run to a for each loop or a for loop, whichever one you desire. I think the for each is probably a little bit better. I look at every single item in that collection, every single control that's in that form, but I look for the controls of a specific type or I look for controls rather that have a specific tag. When I find those, I determine whether they have data in them or not. And if they do, great. If they don't, I warn the user you're missing data. That's one way. The other side of it too would be if I want to loop through data in a record set and find, let us say, a particular record and manipulate that data or use that data for a query. And there's a lot of things you can do with it. This is beginner, again, basic VBA course. And when we come back, we're going to go to another loop called the do while. I'm going to show you just where that is kind of located. The do while is here and do until. And then there's these while, when, and kind of weird loops. We're not going to, I think do until and do while are probably the best ones we can use, because do while typically I like using, like do while you're not at the end of the file. So in other words, you can go through records. That usually works out pretty well. Or do until you're at the end of the file, or EOF. You're going to see that kind of terminology come up as well. So, in any event, I am the database guy. Please, as always, like and subscribe. I think what you're going to find is when you get into the intermediate, it's going to be a little bit more exciting. If we go back to our database just quickly before we end here, let's go into it just one more time. And we go into this form here. We're going to connect a lot of this stuff here. All right, we're going to run code to connect it. And we're going to go and revisit that as well. So to add books and authors, what you would do would be the first thing you will do is you will allow these fields to be, let's see here. Let me put this one on this one here. We got to fix this up. This should be allow additions, no. At this point should be no. Come on, there you go. And right. So you're going to basically, on each one, I can't run allow additions no here because it will shut down everything. This is why this particular form should probably have the books and the authors as the main, or the books as the main and the authors as subform, and then these two should be subforms. Normally I do that. For our example, I did not, which is fine. But what we will do is on this key, you will enable everything, set everything, at least in this form, to add, and then set it to, actually, no, this form is going to be enabled. This one will be, I think we can do edit, not add. Well, we should do add and edit, and I think what would happen is it's fine. You add the author. Once you press enter into it, it'll go into an edit mode, or we could say edit. We'll see. It might work with edit without add. So let's just see here quickly. I know I'm going on, but it's allowing edit yeses. So we should probably be able to just go into there because it's tied to our temp form. So we could be able to just say, and leave it at edit, not even add. All right. And so that button here, everything is enabled. And then you go ahead and you add the author. And as you add to each field, you're going to save that data. When you get down to the last field, you're going to then, after you hit enter, you're going to look to validate the data to make sure it's there. Oh, and as I said, well, you're actually going to validate it with these here. So these are going to come up to the confirm and cancel. And you're going to validate your data with confirm to make sure. And we're going to do this loop with it. Let me do it to loop through everything with a specific tag on it to see if that data even exists. And if it does, great. If it doesn't, warn the user. Cancel, I can always cancel out, delete everything, no problem. So it's going to be our first button we're going to do. But anyway, when we do that, when we code it, and I'm going to show you that. So anyway, as I said, please always like and subscribe. I'm here for you wherever you are. Have a great day, great evening, great morning, great life. And I'll be with you again soon.